Hi everyone, so here we are on chapter 21, and chapter 21 is on neutralization. So this is still dealing with acids and bases, but now we're just going to focus on the neutralization part of an acid-base reaction. Okay, and so let's see, there's no PowerPoint notes that go with this. You will need your own piece of paper for notes, and also you should get out the chapter 21 worksheet because we're going to do some problems from the worksheet that will go along with the lesson. All right, so the first thing you need to know is what is a neutralization reaction? All right, so a neutralization reaction, RXN, that's an N. RXN is the abbreviation for reaction. Okay, so basically a neutralization reaction is an acid-base reaction. Okay, it is an acid-base reaction, and it's kind of like what we call a special type of acid-base reaction. If you remember, when we talked about acids and bases, we said that acid plus base, this is just the generic form of an acid-base reaction. Acid plus base will give us salt and water, okay? And then the salt, when we talk about salt, remember that means a ionic compound, okay? So the salt refers to an ionic compound. So when you have this acid plus base gives us salt and water, this is what we call a special kind of double replacement reaction, all right? It will be a double replacement reaction. If you remember double replacement, that's where we did the foil, where the outer ones come together and then we put the inner ones together. And so you can see why we call these acid-base reactions neutralization, because it will form water. And when we cross out spectator ions, we're going to be left with only the water being produced, like the H+. We're going to be left with the acid, which is H+, and the base, right, which is OH-. Okay, and you can see how that makes H2O, all right? And we'll talk more about that as we go over more examples, all right? But that's just, in general, what a neutralization reaction is. All right, so what I want you to do is take a look at your worksheet. So the worksheet looks like this, okay? And what we're going to do first is we're going to go over number 3. Okay, number 3. So if you read the instructions for number 3, it says complete and balance the following neutralization reaction to show the formation of a salt and water. So notice they give you the acid and the base, and then we have to figure out what the products are going to be. So we have to do our double replacement to find out what the products will be. So what we're going to do is we'll do this one first right here, the first one. Okay, so you're going to stick the outer ones together, so then the H and the OH come together, and that makes what? H and OH make water. Okay, then we will put the inner ones together, K and, so we're putting K and nitrate together. When you are forming new compounds, you need to make sure that you write their charges, okay? We have to do crisscross with the charges. All right, we have to do crisscross with the charges. So nitrate is -1, and if you look on your periodic table, potassium is +1. So then you can see we have a +1 and a -1, so they will already cancel each other out. So then when those form potassium nitrate, we just need one of each, like that. And then you always have to double check to make sure that the equation is balanced, all right? So we have one H on that side, plus another H, that's 2 H's. So we have 2 H's there. Nitrate, which is a polyatomic, stays together, and we have 1 on each side. Then we have 1 O there, and then 1 O there. Okay? Notice that these O's with the nitrate there stay with those ones there, so we didn't count those again. We only needed to count this one as a different O there. Okay, now we're going to do another example here. Let's do the last one right there. Okay, the last one there. So stick the outer ones together. Okay, so let's put the H and the OH together. So we know we're going to make water. Remember, salt and water. Salt is the ionic compound, and then of course we know H and OH come together and make water. Then we stick the inner ones together. Okay, so we have to put iron with sulfate. We need to do crisscross with the charges. Sulfate is -2. Iron, we have to take a look at the iron here. Okay, well, it's combined with hydroxide, and there are 3 of them. So since hydroxide is -1, right? Hydroxide is -1, right? So then that means the iron has to be +3. Okay, so do your crisscross. 3 comes down there, and the 2 over there. So it becomes Fe2, and then parentheses SO4 with the 3 on the outside. Okay? Now we have to go and balance the whole equation. Okay? We have to balance the equation out. All right, so we have 2 H's here plus 3 H's here. See the 3 on the outside? So 3 plus the 2, that makes it 5. Okay, so that's where it gets tricky. Okay, where we have a 3 and a 2 over here, and they're separated. So let's come back and do that one later. All right, so we see the 3 here on the sulfates, right? So 3 sulfates, so let's make those sulfates 3. So we put a 3 in the front here. And then we can see right away that we have a 2 there for the iron. So then let's put a 2 in the front on this side to make those irons 2. So hopefully this will help us fix the hydrogen problem that we were seeing. Okay, so let's see. 3 times 2 is 6. Okay, so 6 plus another 6, right? Because 3 times 2. So 6 plus 6, then that's going to give me 12, right? 12. So then I put a 6 in the front of there, because 6 times 2 then, that will give me 12. Then that will give me the 6 O's, and then that will balance those 6 O's right there, right? Because the 3 on the outside. 3 times the 2 makes that 6. All right, and then finally that equation is balanced, all right? Okay, now take a look at question 3b. Okay, so 3b, write a chemical equation similar to those in 3a to show how the salt KCl might be formed from an acid and a base. Okay, so what we know is, we know what the products are going to be this time. We know that the salt is going to be KCl, and we know in an acid-base reaction, water is also made. So now we're working backwards to find out what the acid is going to be. So we know it's going to have an H in the front over there for the acid. And then we know for the base, it's going to have hydroxide in it, right? Okay, so remember, the other way we can write water as HOH. Okay, so now let's do our double replacement to find out which acid and which base KCl came from. Okay, so we stick the outer ones together. So KOH. And we have to do crisscross with the charges. Well, potassium is +1. Okay, and the chlorine is -1. So since K is +1, we know hydroxide is -1. So when we write KOH, we just need 1 of each. Now we stick the inner ones together. So it's HCl. So we only need 1 of each because hydrogen is +1, chloride is -1, so we only need 1 of each there. Now I'm going to talk about this concept regarding titration, and this is going to involve the very last lab that we're going to do. So the whole titration information that I'm going to talk about is going to be referencing answers to these questions here, okay? And so this is what I'm going to be going over, this part stuff here. Now we're going to talk about titration, which is a lab technique used by neutralizing an acid and a base solution. And when we neutralize it, we can then therefore do some calculations to find the concentration of one of the solutions, because usually one solution is known and the other one is unknown. All right, so what I'm going to do is I'm going to draw a picture for you, and my pictures I know are not super great, but hopefully through this picture you have a better idea of what I'm talking about. All right, so in a titration, we're going to use 2 burettes. If you remember, the burettes are the very long glass tubes, okay? They're very long, and they are used to measure volume, so we're going to have 2 of them. One will contain acid, one will contain base. Okay? And in these burettes, if you remember, they have a tip where the liquid flows out of them, and then it has this little knob or handle on it, which we call the stopcock. Okay, this is called the stopcock, and we can turn this handle, and that will allow liquid to flow out of the tube. Okay? All right, so one of these will contain acid and one will contain base. All right, now also we will use what is called an Erlenmeyer flask. The Erlenmeyer flask is the one with the long neck. Okay, kind of looks like this. And also, let me just raise this up a little. Okay, also this is going to sit on what we call a magnetic stir. Okay, magnetic stir. And inside this flask we'll have a stir bar. That's the stir bar. So let's label some of these things for you. Okay, so this is the magnetic stir. That's an R. Is that how you spell stir? And then this little blue thing in there is the magnetic bar. Okay. And so what we do is, and we'll put some water in there too, we will put some acid or base into the flask. Also, another thing that needs to be added inside of the flask is indicator. Okay, some type of acid-base indicator also needs to go inside the flask. So the indicator, it will turn color to let us know whether the solution is acidic, basic, or neutral. Okay, and the indicator that we are going to be using is called phenolphthalein. All right, phenolphthalein. And there's different indicators that we could use depending on which acid and base is being used, but for this particular lab that we're going to be doing this week, we're going to be using phenolphthalein. So phenolphthalein will turn bright pink when it's basic, and then it will turn colorless if it's acidic. So like it'll be so clear and colorless where it kind of looks like water, and that's when it's acidic. When it is neutral, we will want to try to titrate the solution where it's the pale pink color. So we want, hold on, let's raise this back up. So we want a pale pink. If it's pale pink, that's when it is neutral. And that's just for the particular indicator that we're using in the lab. Okay, and like you want the palest pink color where there's just a small little hint of pink, okay? And you'll see in the lab that sometimes once you get to that point, it just takes like a drop or half a drop in order to turn it that pale pink color, okay? And that's what we're trying to do. We're trying to neutralize the solution. All right, so those are like the main pieces of equipment that we need. Now this magnetic stir that you guys get to use in the lab is pretty cool. And so we put a magnet right inside of the flask. When we turn this on, that bar right here is going to spin. And it's going to stir your solution for you so that you don't have to do it like with a stirring rod or anything. Okay? And so this is basically your setup for a titration. And the whole point here, right, the colors of the indicator and everything. It is really important that we put in the indicator, otherwise we will not know when the new solution has been neutralized because it's not turning color to let us know. And so also when we get to this pale pink color right here, the pale pink color when it's neutral, this is when we know we have reached what is called the end point in the titration. Okay, so the end point in the titration is where it turns that pale pink color when the solution is neutral. So we are going to be titrating a strong acid and a strong base. So at this end point, the pH is going to be 7. It's going to be neutral. Okay, and that is telling us that we need to stop the reaction when we get to that point. Okay, also at this so-called end point, this is where we know, sorry, it should be an O, where the moles of acid, oh, that looks bad. Let's write that again. Where the moles, I'm putting moles of A, which is acid, equals moles of B for base, okay? Where the moles of acid equals moles of base. That is the end point where the pH will equal 7. This end point sometimes is also referred to as the equivalence point. Okay, the equivalence point. So let's try to squeeze all of this in somewhere. All right, the equivalence point. All right, where moles of acid equals moles of base. And that's when we know that we have equal amounts of H plus and OH minus. Okay? All right, now also when we're doing this titration lab, one of these solutions is going to be what is called the standard solution. Okay, the standard solution. So the standard solution for a titration is the solution that has the known molarity. Okay, known molarity. So when we do this lab, one of these is going to be known and one of these is going to be unknown. Okay, and I think in the lab, I believe it's the acid will be known. Oops, known. And then the base will be unknown. Okay, so when we collect the data of how much acid and base we use to neutralize the solution, then we're going to plug in the information into this equation. Okay, and then now I'm going to go over some of this equation stuff. The equation that we're going to use, so I'm going to scroll this so we have some room to write. Okay, so the equation that we're going to use to solve for all this stuff is MaVa equals MbVb. So this equation looks familiar because it's very similar to the dilution equation that we use. So A stands for acid, so the molarity of the acid multiplied by the volume of the acid equals Mb, so B is for base. So in other words, this will be known in the lab. We'll calculate or we'll measure how much volume we use to neutralize the solution. We will therefore also record the amount of base that we used, and then we would solve for this mathematically when we're done with all the lab procedures. Okay? And so this equation also, as it was in the dilution equation, the M1V1 equation, you're basically saying moles of acid equals moles of base. Okay? If you take a look at the back side of this worksheet, now we're going to practice using the math. Okay? There are some equations up here that you can use to answer the problem. So these are all the equations that you can use and the concepts you can use. Okay, you know moles of acid equals moles of base. You could use your molarity equation. And then this is the MaVa equals MbVb equation. All right, so it says for questions 8 through 11, write the balanced neutralization equation, then solve using the above equations. All right, so first it wants us to do acid plus base gives you salt and water. So we will do number 8 together. Okay, we'll do number 8 together. So we have ammonium hydroxide with HCl. So let's write out that equation first, right? HCl plus ammonium hydroxide. Do the double replacement, so we know HOH come together to make water. And then the ammonium and the Cl come together, one of each, because the ammonium is +1 and chloride is -1. So then we only need one of each. And then you always double check to make sure it's balanced, and it is balanced. All right, so now we're going to read the question with the numbers and everything and see which equation we should use to answer the problem. All right, calculate the moles. Okay, so we want to find volume. So volume is what we're trying to find. So we're trying to find the volume if we have this much base required to neutralize, so this will be a keyword here, 15 mils of 0.2 molar HCl. So this equation right here is also known as our neutralization equation, okay? So that is telling me that I should use that equation. And also MAVA, so that means I have to have information for acid and I have to have information for base, and I do in the problem. So that's the equation we're going to use. So let's go ahead and write that out. I'm just going to write it up here just because I do not have enough room over there. So let's see. I'm just going to write it over here. Okay, so this is number 8. Oops. So we're going to use MAVA equals MBVB. So let's plug in the numbers, right? So molarity of the acid is 0.2. Volume of the acid is 15 mils. This equation, it is okay to leave it in milliliters as long as the units are the same. Molarity of the base is 0.5. Right? And then the volume is what we're trying to solve for, so that's X. All right, so we just finish out the math and we solve for X. And then if you do it correctly, you can see that these answers here are already provided for you in the problem, so you can see if you're doing it right or not, okay? So in parentheses, all right, after the problems, those are the answers. Okay, so go ahead and finish the rest of the worksheet, and if you have any questions, make sure you ask. All right, see you later. Bye.